Hello everyone. So welcome to the JEE Main 2019 solution of mathematics paper, and this time we are going to talk about 11th January 2019 morning session paper. So let's begin with the first question. Let fx, a function, is given in two different intervals -2 to 0 and 0 to 2. Another function gx is defined as mod of fx plus f of mod x, right? Now then in the open interval -2 to 2, we have to talk about continuity and differentiability of the function gx. So let's talk about the function gx, for which you need to talk about f of mod x and mod of fx. So let's start it. When you talk about f of mod x, this will be equal to, when you substitute here, -1 when mod x is between -2 and 0, which is not possible. So clearly there is no point of substituting in the first case. Second, when you substitute here, you get mod x square -1 when mod x is between 0 and 2. So here you can see, when you change it into intervals like -2 to 0 and 0 to 2, you will find the same result as x square -1. So there is nothing extra. You can directly write x square -1 for the interval -2 to 2. This is clear. Moving to the second part, that is mod of fx. This time this will be equal to 1 or mod of x square -1 according to as x is in the interval -2 to 0 or 0 to 2. This is clear. Now we can break this one further. So breaking it further, we can write it. This is equal to 1 when -2 to 0, then minus of x square -1 when 0 to 1, and finally x square -1 when 1 to 2, right? Okay, when you add the two functions to get gx, you need to break it into different intervals as per mod of fx and f of mod x. Now f of mod x has simple interval -2 to 2. You have to break it accordingly now mod of fx. So breaking it like -2 to 0, when you add, this is 1 and the other function is always x square -1. So you get here x square. Moving ahead, 0 to 1. 0 to 1, it is negative of x square -1, while the other function is x square -1. So it becomes 0. Moving ahead, twice of x square -1 when x is in the interval 1 to 2. Clearly this is continuous in the open interval -2 to 2. As you can see, around 0 it is 0 and this one is also 0, while around 1 this part is 0 and the other is also 0. Now let's talk about the differentiability of the function. For differentiability, let's find the derivative leaving the endpoints. This gives you 2x -2 to 0, 0 for 0 to 1 and 2 into 2x when 1 to 2. Now when you check derivative about 0 from left side and from right side, what you observe? It is approaching to 0, right? So g dash 0 left hand derivative as well as right hand derivative, both are equal, meaning that the function is differentiable. When you move for point 1, left hand derivative at 1, you can see this is 0, while right hand derivative at 1, this is coming to be 4. So clearly the function is not differentiable at x equals 1. So we observe this function is not differentiable at one point, that is option number 2 is the correct answer. I am sure this question is clear from limit, continuity and differentiability. Moving ahead to the next question. The plane containing the line, one line is given, and also containing its projection on the plane 2x plus 3y minus z equals 5 contains which of the following points? So here we can see required plane is containing this line as well as containing projection of this line on this plane. So clearly the normal vector of the required plane is perpendicular to this line as well as its normal. So here we can write the required plane as x minus 3, y plus 2, z minus 1, then 2 minus 1 3 and 2 3 minus 1 equals 0 as the equation of required plane. Just simplify this equation. This gives you 1 minus 9, that is minus 8 into x minus 3. Moving ahead, minus 2 minus 6, that is minus 8. So, it becomes plus 8 y plus 2, then 6 plus 2, that is plus 8 z minus 1 is equal to 0, or we can rewrite it as x minus y minus z dividing by minus 8. We have minus 3 here, correct? We have divided by minus 8, so it is minus 2 and this is plus 1, or simply x minus y minus z minus 4 is equal to 0 as the required equation of plane. X minus y minus z minus 4, let us rewrite here so that you can cross check by substituting every point. Now, when you substitute points one by one, you can clearly see that option number 4 is satisfying this plane, right? So, the required answer for this question is option number 4, because on substituting 2 comma 0 comma minus 2, it is being satisfied. Let us move on to the third question of this paper. Let f from R to R defined by fx equals x upon 1 plus x square. Then we have to find the range of this function. Pretty well known question. Y equals to x upon 1 plus x square. Cross multiplying, we can rewrite y x square minus x plus y is equal to 0. Now, this would be defined when d is greater than or equal to 0, the required constraint. That gives you 1 minus 4y square greater than or equal to 0, or y belongs to minus half to half. Now, coefficient of x square is y. If you say y equals 0, you are going to get from here x also 0. X equals 0 is part of domain. So, y equals 0 is also required in range. So, correct answer is minus half to half, the complete part. So, this is the required result. Let us mark and mention as the answer. Let us move on to the next question of this paper.